What's up, guys? I'm back on YouTube. It has been a long time, guys, since I uploaded a video or did a YouTube show, a YouTube live stream session. Uh, Basically, I've been very busy for the past 2 months, guys. But luckily, I found some time today to share some kind of knowledge with you guys. And today, what I want to do is to basically help you understand how to get started with Metal. I know that if you are completely new to that graphics API from Apple, Metal, it may be a little bit confusing on how to get started. There are several resources out there, and even though they're good, I don't think they fully break it down to you, no, or for you to understand it completely. So what I want to do today, guys, is basically go over the API, and hopefully after this live stream, you will have a better idea of how to render, you know, items, objects using the Metal API. All right, guys. Before I begin, forgive me because I have not been doing this for the past 2 months, so I'm a little bit rusty, as you can tell. But my name is Jero Serrano, and if this is the first time that we meet, I basically develop game engines. This is something that I love doing, and feel free to check out my other videos on how to develop your own game engine. And also, if you have any questions for me related to game engine development or about Metal, feel free to post them in the chat, and I will try to help you out. All right, so let's get started, guys. Let me share with you my screen so that way we know what to do. All right, so what I'm gonna do here, and I'm just checking that everything is going well. All right, so let's say that you want to get started with Metal and you want to understand how the graphics API works, and whether you come from OpenGL or not, you still, I'm lost. I don't know what to do whenever I open up the Xcode project that is given to you by Apple. It's so confusing. There's a bunch of stuff there. I do not know how to dissect this. Well, what I'm going to do, I'm going to dissect every line of code that you need to worry about. All right. So what you see here on my monitor is a simple project that I created. All right, where I break down what is the most important things that you need to focus on. All right. So before we begin, I want to tell you this. Whenever you are working with Metal, understand this, that everything is an object. All right. And before you create an object, you need to create a descriptor that will be used as an argument during the creation of that object that you want to create. For example, a pipeline, the graphical rendering pipeline, that is an object, right? And you needed to create that object, you need to create that pipeline. Well, before you allocate memory to create that object, you need to create a descriptor that will basically inform the, the pipeline creation, the pipeline constructor function on how to construct that object. All right, and it's confusing, but the idea is this: whenever you want to create an object, you need to create a descriptor about that object. You want to create a rendering path, well, you need to create a rendering path descriptor. You want to create a texture, well, you need a descriptor about that texture. Everything requires a descriptor. So have that in your mind whenever you are working with Metal, because that can get a little bit confusing. So all right, so let's begin. And I'm gonna be sharing this code project, or this sample code on my in my Discord server, so that way it's available to you if you want to use it. But again, the whole point of this video is to basically go, and explain to you what is really, how everything works and what you should focus on. All right, so Whenever we run this project here, right, which is a simple project, the first function that it gets called by Xcode, right, by the project, is gonna be this function called init with metal kit view, all right. So it's gonna get called. This is basically your initialization routine, all right. So what do you need to do first? Well, the first thing that you need to do, the first step, just like I'm highlighting it here, is that we need to get a GPU device, all right? So that's the first thing that you need to do no matter what. You need to get that GPU device for you to be able to create other objects, all right? Now, the second thing that you have to do is you need to create a pipeline, all right? Now, if you recall, our rendering pipeline consists of several stages, right? There's the, we have the shaders, the vertex and the fragment shaders. You can also basically configure your blending. You can upload the textures, etc., etc., etc. Well, we need to create our pipeline, all right? Now, the first thing that we're going to create and that is required by a pipeline is the shaders, all right? So we're going to focus on that in the next couple of lines of code, all right? So the first thing that we want to create a shader, right? So what we need to do first is we need to create a library, all right? And this library will allow us to basically do what you do in OpenGL, such as compile, load, and link your shaders. Well, we're going to do it here with this library, all right? So we're going to get our library using the metal device, and the metal device is basically our GPU device that we got here, right? And so we're basically going to call metal device new default library, and that will give us a library which we will then be able to use to create our shaders, right? Now, once we have the library, now we can create our vectors and shaders, our fragment and shaders, right? In Metal, they call them functions. All right, so in this instance here, we're gonna create our vectors function program using the MTL function, and we basically are gonna use our library that we created previously, and we are going to say new function with name, right? Which is equivalent to saying new shader with name, right? And then we're going to give it a name of our shader, vertex shader. Then we're going to use the same. We are going to do the same to get our fragment shader, right? We're going to give it a name. We're going to use the library, and then we're going to say new function with name, fragment shader. All right. Now, these two names that you see here, right? Those are basically the names of your shaders, and I'm going to go into the shaders metal file so you can see. So in here, we basically have, the shaders, vertex shaders, and the fragment shaders. All right. So with these two lines of code, what we are doing is basically akin to what you do in OpenGL, such as when you compile, you load, and what do? You compile, you load, and you link your shaders in OpenGL. Well, this is exactly what we are doing here in these 3 steps. It's just a lot more simpler than how they do it in OpenGL. All right, so we have our shaders all set in our pipeline. Now, what is next? Well, you need to tell you need to tell Metal how your data is organized, all right? What to expect, how your data is represented, right? So to do that, what we need to do, we need to use a vertex descriptor, right? And so here we are creating a vertex descriptor object, all right? And what we are going to do next is we're going to tell Metal, hey, my data is represented this way, all right? So the data that we're going to be loading into our buffers, the attributes data that we're going to be using is basically found here, all right, in this array here, quad vertex data, all right? So this is basically the vertices of our rectangle that we're going to be rendering, all right? So we need to tell Metal, this is how our data looks like, all right? So that way, how we do that is that we provide a descriptor. And here, the descriptor We provide a format, right, which is a float 4, right? We have four components in our vector. And then we provide a buffer index and the offset, which is equals to 0. Now, if you happen to have UV coordinate data, then you would also provide that format in here, right? Like you would tell, hey, my format for my UV is going to be float 2. If you have normals, would be float 3. Basically, what I want you to keep in mind is this: you need to tell Metal how your data is represented using a vertex descriptor object. All right, and then you also need to provide a stride and stuff like that. All right, so this is basically the minimum setup of components that you need to create a pipeline, right? And the next line that we're going to see here is basically the following, right? What we did with all of this is basically, so let's recap. We created a library that will hold our shaders functions, and we basically created a vertex descriptor that tells Metal how our data is represented. With that data, we're going to create a render descriptor for our pipeline. All right. Remember how I told you before you create a pipeline, you need to create a rendering descriptor. Well, that's what we're going to do right now. Right. So in this line of code here, we are going to create a render pipeline descriptor. All right. And then we're going to inform the descriptor how our data is represented. It can be found here. So as you can see, we created a descriptor, and we told the descriptor, you know, our shaders, our vertex descriptors, etc. We can add more stuff here, obviously, in the descriptor. For example, we can you need to tell the descriptor about the default frame buffer pixel format that that you are going to be using, right? In this case, it's going to be pixel format BGR8 you normalized, right? And now once we have that descriptor, right? Guess what? Now you can create your pipeline. So here, render pipeline state, we basically use our meta device, our GPU. We use the function new render pipeline state with descriptor, and we pass in our pipeline descriptor that we just created earlier. With this, we have basically created a pipeline object that we will be using during our draw. All right, I'm gonna stop for a little bit because if you have any questions, guys, feel free to ask in the chat. I will explain to you how this works. I'm hoping I'm doing a good job. I haven't been doing live stream for a while, so I know I'm a bit rusty. All right, so we have our pipeline descriptor. Now, before you use the pipeline during a rendering draw, we need to, we need to somehow provide the attributes, right? The attributes basically contain the vertices of our model, right? So where do we load that data, right? Well, we load that data in metal buffers, all right? So what we're going to do here, we're going to create a metal buffer called vertex buffer, right? And we're going to load it with our data that I showed you earlier, which is in here, all right? Quad vertex data. All right, so vertex buffer, right, it will be the buffer, the object that contains our data, right? So again, to do that, we're going to use metal device. Then we're going to say new buffer with bytes, and we're going to pass in our array of data, quad vertex data. We're going to need to provide our size of it, and then options. So here we're basically passing the pointer, and we're passing it. Hey, this is the size of our array that we are passing in. And now we also need, obviously, we need to provide a space transformation data into our pipeline, right? We need, for example, our model view space or our MVP model view projection space transformation, right? We need that data in order to use that in our shaders. Well, to do that, we use you also create a metal buffer. In this case, my metal buffer is called uniform buffer, and I created right using almost basically the same syntax. Metal device. Then what I do here, which is different than what I did earlier, is that in this instance I use new buffer with length. In this one I use new buffer with bytes, right? And the reason why I do this is because all what I'm doing is I'm just allocating the size of what I expect my buffer to be, because my uniform data is going to be constantly changing, right? So all what I want to do is allocate enough space for me to later load more data over and over into that buffer. So that's why I'm creating this buffer with new buffer with length. All right. You're going to see later on how this works. All right. So at this point, we have basically completed our initialization of our pipeline. We're ready to start drawing. All right. So how do we start? Basically drawing with metal. Well, before you start drawing with metal, you need to create a rendering path, and the rendering path will basically link your pipeline and your attributes data, right? And it will basically commit that into the GPU. The rendering path will be the one responsible for all of that. All right. So this function right here, draw in empty key view, will be called constantly. This is basically your game loop, right? Will be constantly be calling right after you have called the initialization function. Now I'm gonna skip this section for a little while, for a bit. I'm gonna come back to it. Okay, so like I told you, we need to create a rendering path descriptor. All right, so how do you create that? Well, we create an object using view, which is my current default view, drawable, and we ask, hey, give me your current path descriptor, and this is how you do it, right? We need a descriptor, right? Now, in that descriptor, we basically are going to tell it several behaviors of how we want it to behave. All right. So for example, here we want to say, hey, when you load the the color attachment, right? The texture, the default frame buffer, when you load it up, I want you to clear it. All right. That's what we're doing here. All right. And we'll clear it with what? Well, then we say, I want you to clear it with this color, right? And this is going to be color white. And then we can tell, hey, throughout the lifetime of this rendering path, I want you to store the content. All right, I want you to store it because I may want to use the content for something else, obviously. But when you come back to it, I want you to clear it again. That's what this is doing here. All right. Okay. So now we have our simple descriptor. As you can see, it's very simple, but it can get more complex than that. All right. So now we need to send our data we need to send our request to render something to the GPU, right? To do that, we need to get a render encoder, right? And to get a render encoder, you need to get a command buffer, right? The command buffer will essentially be the one responsible taking everything onto the GPU, right? And the render encoder will help basically the command buffer understand the whole instructions that you are sending it to it. I know it can be a little bit confusing, but believe me, this is how it works. And once you understand this, that before that you commit something to the GPU, you need a render encoder. Everything will be a lot easier for you to understand. Just keep that in your mind. You need a render encoder, no matter what. All right. So we are going to create a render encoder here, right? And note that we are using a command buffer that we created here, right? And we create a render encoder using our render path descriptor. All right. So that way, it knows exactly how to, what to do during every rendering pass. All right. So now, here's where we link our pipeline with our rendering descriptor, all right? Or in this case, our rendering encoder, all right? Here, we are basically saying, hey, during this rendering pass, I want you to link my pipeline. This is the pipeline that we created earlier, render pipeline state. Remember, we created it here. I want you to use it during this pass, and this is where we do that. We say render encoder, set render pipeline state, rendering pipeline, whatever, right? That's where we link it. Now, in this section right here, we are basically telling the encoder, hey, I want you to use this data for my attributes and this data for my space transformations, right? We're basically linking that data, the attributes and the uniforms into our pipeline so that it is used during that rendering pass. All right. So now you may be wondering, okay, so how do you know that this will be our attributes and this will be our uniform data? Well, all of that is basically happens with these two indices here, 0 and 1, right? Okay. So what happens is that our pipeline knows the shaders that we are using, right? And if you notice, let me go into my vertex shader, right? My vertex shader, we will receive our attributes data, right? Which is our vertices, right? And if you notice here, my uniforms has an index of 1 here. Well, that's what I'm doing in here. That's a 1. This is my uniform, all right? My vertex data has an index of 0, which is over here, all right? And that's how it knows how to link my attributes and my uniform when I'm using my shaders, right? I'm basically informing the GPU where my data is found at, all right? So vertex buffer is gonna be, used in here in my shader as my vertex n, and my uniform is gonna be used here, all right? And that's how we do it. Now, once we have done that, we are basically done with our rendering pass, right? The next thing that we need to do is we need to basically just send a command to draw our primitive. In this case, we're drawing a triangle. All right, we provide the start of our vertex, which will be 0, and then the count of our vertices, which is 6. And then we basically we do the following steps. We end the encoding by calling an encoding, and then we present the drawable, and then we commit what we just did onto the GPU, and you are done. Now, before I press run here, I want to explain about what's going on here. Now, in the update transformation, what we do is that we are constantly changing our matrices, all right? Our projection, our model view matrix, all right? What we want to do here is we want to rotate our rectangle, right? So in here, what we do is that we create basically, I forgot to tell you this. Uniform here, what you see here is basically a structure, right? That contains our projection matrix and our model view matrix, all right? And if you recall, this is what we did here. We allocated space for that uniform, for that structure here, but we did not load it with any content, all right? So in this section right here, what we do is that we're going to load it with content, right? We have our projection matrix, which we calculated during the initialization, and it's found here. We do this one, right? And then what we do is that we want to rotate our rectangle, right? So here's where we compute our model matrix, our view matrix, right? And we basically, once we have our model view matrix, what we do is that we do a mem copy, all right? Where we basically copy that data in our uniforms object here. We provide the data into our uniform buffer content, all right? Our uniform buffer content that you see here is basically this buffer right here, which we created earlier, right? We were basically copying that data from uniforms, which is this guy, which contains all of this data, well, basically this data, right? We are copying that content into our uniform buffer content and providing the size, and then we're constantly updating this. This uniform data will be used up by our shaders in here, right? Uniform data, right? Because what we do in our shader is basically we are getting our vertices, right? And then we are transforming those vertices by our model projection matrix, view matrix, position, and then out, and then we simply use the fragment shader here. And then this is basically all what you need to do to create your first application with Metal. Just keep this in mind. You need to get a GPU device first, and then you need to create a pipeline. But for you to create a pipeline, you need to create a pipeline descriptor. And before you can load data into your pipeline descriptor, you need to create, your vertex shader and your fragment shader, which is what you expect to do. You also need to tell the pipeline how your data is represented, right? You're going to have vertices, UV coordinates, you're going to have normals, you may have tangent data, bitangent data, stuff like that. And you need to tell Metal, this is how my data is represented. This is the format of my data. You need to tell it, because else it will not know what to do with it. All right. And once you have that data, your descriptor, right? And then you can load then you can create a pipeline using your descriptor. And once you have your pipeline, you're done. And the next thing that you need to do is basically create a rendering path descriptor, which you will use to create a render encoder, which will be able to send all of that data to the GPU. And that is it. All right. I know it may sound a lot, but the whole idea, if there's anything that I want you to remember from this video, is this: you need to create a descriptor before you can create an actual object that you are going to be using it throughout the lifetime of your game. All right. So let's run this, and what you're gonna see is something simple. You're gonna see basically a rectangle, basically rotating, and nothing more than that. I wanted to keep it as simple as possible, because when I'm learning something, I want to get rid of all of that noise, right? All of the things that are not really important to me at that moment. And I feel that some tutorials, they just populate their tutorials with so many other stuff that it basically makes it hard for people to understand what really is going on. So here, what you see is basically your, our simple rectangle, right? Rotating, right? The data, the vertices of our rectangle were basically loaded into our buffer, right? Our buffer here, which is a metal buffer, right? All of that data that was loaded into our buffer is basically here. The data that is basically rotating our rectangle is passed by our uniform, and we are doing a mem copy during every game tech, right? Basically changing our model here, our space, right? Also, during our rendering pass, what we do, we create a rendering path descriptor, which we later use to create a render encoder. And that render encoder basically helps us link our pipeline to the rendering path, and also link the data that we're going to be using in that pipeline. And that's basically how everything works. I'm gonna be sharing this sample code with you guys in my Discord server, so feel free to join. And the reason why I'm going to do that is obviously I want to help you, but you can use this whenever if you are learning Metal for the first time, right? Because if you have been trying to learn, you may have noticed that, let's say that you want to create a new project in Xcode, all right? And let me go name, and I'm going to call this test YouTube, whatever. All right. And let's put it into download. Boom. And now we're going to create a new project here. So let me bring this up over here. All right. So when you create a new project in Xcode, this is what you see, right? You're gonna see if you go to renderer, right? This is the file basically in charge of doing the whole rendering, right? You are going to see a bunch of stuff here that you have no idea what in the world is this, right? And then if you go into the initialization function, you're gonna see this, and you're gonna see load metal view, and what are they doing here with the vertex descriptor. And then if you keep going, this is how they load the assets. There's not really much of explanation of what's going on here. Then they are updating the buffers. By the way, they are using triple buffering here, but they don't tell you that, right? And especially if you're new, you are not going to know what the heck triple buffering is or how to set it up, but they do that here, right? And then in your game tech, in your game loop function, you can see how they create a vendor pass descriptor, but then they do all of this nonsense here, right? Which makes things a lot complicated for newbies to understand. I'm not saying that it's nonsense in the sense that it's useless. No, I'm saying to a newbie, this is like, what in the world are you doing, dude? Like, what is this, right? So when I saw this, I'm like, come on, guys, like, we can make it easier for people to understand. So that's why I actually did this simple code example here for you to understand. So I'm gonna be sharing with you guys this function, render.m shaders metal and shaders type, right, in my Discord server. And what you can do if you want to learn how to use metal, whenever you create a new Xcode project, just simply replace the files that I'm going to be sharing with you with the files that you find here, which is render.m shaders metal and shaders type. You can just replace them and you should be okay. You should be ready to go. Because I firmly believe that once you know the basics, and once once the clutter has been removed from what you want to really focus on, from this point on, you can build up, right? Well, from this point on, you can now render a cube instead of rectangle, right? Because now you are just going to provide a different set of data here, right? Right? You can shade your cube by providing more like your normals for your vertices, and UV coordinates if you want to provide a texture, stuff like that. So that is it, guys. And I really hope this was helpful, guys. I'm hoping to be back on YouTube more constantly. Like I told you guys, I was very busy for the past 2 months. But I really missed going live on YouTube and doing videos. So I'm going to try to do this as much as possible. Let me know if this was helpful. Let me know if you like this, me going through a tutorial on metal. This is basically what I feel I'm good at, and what I want to become even better at is with graphics APIs, especially metal. So let me know if this was useful to you guys. So yeah. Hey man, how are you? Hey man, thank you. I'm really, I'm glad that this is helpful. So, um, like I was saying, I'm thinking of doing this more often. Maybe next Saturday or Sunday, I'm gonna go live again. And now that we know how to render a rectangle, we can now render a cube, and I can show you how to load data for you to be able to shade your cube and use the normal vectors for lighting and stuff like that. So I want to keep this as simple as possible, so that way you guys have a really good idea of how to use metal. All right, guys. Thank you for joining. Thank you for joining Ultra Instinct. Thank you for your comment. I really appreciate it. And I'm happy to be back on YouTube, guys. It was 2 months of hard work. I cannot share much, right? But basically, I've been waking up at 4 a.m. to get some work done. It has been a lot of work for the past 2 months, and I'm very thankful for that, and and I feel blessed that you know uh, I've been having a lot of work lately, but I also needed a break, and I was missing working on my game engine and doing YouTube videos. All right, guys, thank you so much for joining Ultra Instinct Coder. Thank you so much for your comment, and I hope to see you guys next week. Thank you, and we'll see each other again. Bye, guys.